Assalamualaikum to Dr. Irfa. My name is Dania Adilah Binti Mohammad Zamzillah from BA 2423B. So, today I would like to present about my descriptive measures and hypothesis testing. I choose mental health as my topic, and my indicator is the number of disability adjusted life years dailies per 100,000 people due to depressive disorders. So, this is my sample data. It was about the number of disability adjusted life years dailies per 100,000 people due to depressive disorders. In this sample data, I take 10 years for my number of observation, which shows the year from 2010 to 2019. In United States, the number of disability adjusted life years dailies per 100,000 people due to depressive disorders is declining from 2010 to 2019. Dailies are the cumulative number of years lost due to illness, disability, or early death and excess disease burden. Depressed persons often have other mental health issues. Depression frequently accompanies anxiety problems. Overwhelming anxiety, fear, concern, and panic plague anxiety disorder sufferers. These feelings may persist and disrupt normal life. In the next slide, for my descriptive measures, there are different variables, which is the first one is mean. In average, the number of people dailies due to depressive disorders in United States is at 792.02 people. For the median, the middle point of data is located at 782.66. Then for the mode, I have collected all my data, but there are no mode can be detected throughout the data sample, as all of my data are unique. The minimum value, which is the lowest people of dailies suffered from depressive disorder, is 774.79 people in 2018, while the maximum value of this is at 824.83 people in 2010. In this particular case, the sample variance and standard deviation are calculated to be 391.61 and 19.79 respectively. Other than that, the coefficient of variance value is 0.02, which helps to determine the expected risk and expected return for investment. Furthermore, we have skewness, which helps analyze a dataset structure and features, revealing its distribution and outliers. According to my data, the value of skewness is 0.79, which the peak of the skewness is on the left. As we go further, it is about kurtosis. Values around 3 are desirable. My data have a kurtosis value of negative 1.1519, which is less than 3. This type of kurtosis is referred to as platykurtic kurtosis. This distribution curve has long tails. Outliers can be measured with 3 methods, which are z-score, scatter plot, and histogram. For this case, I use scatter plot. According to the data, the number of person dailies who suffer from depressive disorders is decreasing on an annual basis as indicated by the dataset. As shown in the scatter chart, the graph is falling. Major depressive disorder is treatable, thus good therapy can reduce symptoms. Last but not least, I would present about my hypothesis testing. This is the step that I have taken to conduct the hypothesis testing. Firstly, I would define the null hypothesis, which is HO, and alternate hypothesis, which is H1. In this study, I will be using a one-tail test because I am only analyzing the direct data, which is the number of dailies per 100,000 people with depressive disorders in the United States. For this set of data, my null hypothesis HO is 792, which indicates that the number of people dailies who suffer from depressive disorders can be equal to or greater than 792 people. It will be accepted until contradictory proof appears. Moreover, my alternate hypothesis 792 requires a result below 792 to be true. Due to the fact that HO is more likely to be correct, rejecting the null hypothesis would provide strong statistical proof that HO is false and H1 is true. The next step, I choose the significance level where 5% of significance level is chosen as it is commonly used. The third step is to choose the statistic that will be used for the test. The z-test statistic and the t-test statistic are the two types of test statistics. The true value of this dataset is unknown. Hence, I use t-test statistics. Initially, in order for this formula to function properly, I need to ascertain the average number of people dailies who suffer from depressive disorders. The average number of people dailies who suffered from depressive disorders from 2010 to 2019 is 792. The t-test statistic is 0.0031. In order to determine whether or not to accept 792 as the average number of people dailies who suffered from depressive disorders, I have made the decision to utilize the critical t-test, which is 1.833, to identify rejection region and non-rejection regions, as well as the decision rule to identify regions that are rejected. The crucial test of negative 1.83 does not reject the null hypothesis as shown in the diagram. The reason for this is that the t-test value, which is 0.0031, is located under a non-rejection zone. To support this assertion, I employ p-value method to accept HO and reject H1. We reject the null hypothesis if the p-value is less than alpha, but not if it is bigger. The p-value in my dataset is 0.50, which exceeds alpha 0.05. This indicates that the data should not be rejected. The last step is to make a conclusion. The hypothesis test shows that I do not reject HO of 792 as the average number of people dailies with depression disorders in the United States from 2010 to 2019. There is sufficient evidence to support the claim that between the years 2010 and 2019, the average number of people in the United States who suffer from depression disorders may be equal to or greater than 792 people. This conclusion may be reached since the result is successful in accepting the null hypothesis HO. That's all for my presentation. Thank you to Dr. Ifa for listening, and Assalamualaikum.